Hello everyone. In this lecture I will discuss the principles of information security. I will first discuss what is information security, then I will discuss what is a security attack and what are the different kinds of security attacks, and what are the controls that we can use to defend against them. Then I will explain the security design principles and end with a brief discussion on the difference between data and information. So why do we need to protect our information? Information is an important strategic and operational asset for any organization. The ubiquitous adoption of computing technology has enabled us to be more productive, and the advent of internet has allowed us to access a host of information with only a click of the mouse. However, this also carries with it a host of security issues. If the information on the systems used by our employers or our banks becomes exposed to an attacker, the consequences can be devastating. We could suddenly find ourselves out of funds. Our employer could lose millions of dollars, face legal prosecution, and suffer damage to its reputation because of a system configuration issue, allowing an attacker to gain access to database containing personally identifiable information. Similarly, consider a payroll database in a corporation. So it must be made sure that the salaries of individual employees are not disclosed to arbitrary users of the database. Salaries should only be modified by those individuals who are authorized to do so. Paychecks should be verified by individuals different than the ones who issued them, and paychecks should be printed on time at the end of each pay period. So if we gain a good understanding of the basics of information security, we are on a strong footing to cope with changes as they come along. So what is information security? Information security is defined as protecting information and information systems from unauthorized access, use and disclosure, unauthorized modification, and unavailability to the legitimate users. So it means that we want to protect our information and systems from those who would seek to misuse it. So the three primary concepts in information security are confidentiality, integrity, and availability, which are commonly known as the CIA triad. So let's first look at confidentiality. Confidentiality refers to information protection from unauthorized read operations. It is a necessary component of privacy and refers to our ability to protect our data from those who are not authorized to view it. So let's first look at confidentiality. Confidentiality refers to information protection from unauthorized read operations. It is a necessary component of privacy and refers to our ability to protect our data from those who are unauthorized to view it. So the confidentiality can be compromised in a number of ways. For example, a person looking over our shoulder while we type a password, an email attachment that is being sent to the wrong person, or an attacker penetrating our systems. Let's look at another example. Consider a scenario where a person is withdrawing money from an ATM, and there are a number of ways in which the confidentiality will be maintained in this scenario. The person will hide his PIN number and the ATM card he's using. The owner of the ATM will maintain the confidentiality of this person's bank account and the balance in it, and the bank will maintain the confidentiality of the transaction with this ATM and the balance change in the account. Integrity refers to the ability to prevent our data from being changed or modified in an unauthorized or undesirable manner. For example, if an attacker were to alter the data that contained the results of medical tests, we might see the wrong treatment prescribed, and this could potentially lead to the death of a patient. Therefore, integrity involves several goals: data integrity, which ensures the original information is not modified; origin integrity, which ensures that the source of data is not modified, and this is usually maintained through authentication. Similarly, there is semantic integrity, which enforces the logical meaning of the data and its relationships. For example, if a newspaper prints information from a leak at the White House but attributes it to the wrong source, in that case, the data integrity is being ensured. However, the origin of the source of information is not being ensured. Therefore, this violates the origin integrity. Availability refers to the ability to access our information when we need it. It ensures that the access to information is not denied to those subjects who are authorized to access it. This can result naturally from power loss, from operating system issues or application problems, and it can also be a deliberate attempt by an attacker. So when an attacker tries to block availability, it is known as a denial of service attack. An example is a Smurf attack, in which a system is flooded with spoofed ping messages. So this creates high computer network traffic on the victim's network, which often renders it unresponsive. A security attack can be explained in terms of three things: vulnerability, threat, and risk. Vulnerability is a weakness that can be exploited to harm us. Threat is something that has a potential to cause harm to our assets. And risks are the potential loss or damage as a result of a threat exploiting a vulnerability. So let's look at an example to get a better idea of these three things. Consider a system that allows weak passwords. So in this case, the vulnerability could be that the password is weak and is vulnerable to dictionary or exhaustive key attacks. The threat in this case is that the intruder can exploit the password weakness to break into the system, and the risks in this case is that the resources within the system are prone to illegal access, modification, or damage by the intruder. So now let's look at the types of security attacks. These attacks can be classified into four main categories. Number 1, interception. Number 2, interruption. Number 3, modification. Number 4, fabrication. Interception attacks allow unauthorized access to information. For example, unauthorized file viewing or eavesdropping on phone conversation. These attacks primarily affect the confidentiality of information. Interruption attacks cause assets to become unusable or unavailable. For example, a denial of service attack on a mail server. These attacks primarily affect the availability of information. Modification attacks tamper with our asset. For example, accessing a file in an unauthorized manner and altering its data. These attacks primarily affect the integrity of our information. Fabrication attacks allow unauthorized access to the system and the insertion of false objects into it. For example, gaining access to a person's email and sending messages on the person's behalf. And this makes the recipients of the messages believe that this message is indeed coming from the actual person, when it's actually not. So these attacks primarily affect the integrity and authenticity of the information. So in order to protect against these security attacks and mitigate the risks involved, we can use measures to ensure that a given type of threat is accounted for. So these measures or controls are divided into three categories. Physical controls, which protect the physical environment in which our systems sit or where our data is stored. For example, using gates, locks, guards, and cameras. The idea is that if an attacker is able to physically access our systems, he can steal or destroy the system and information. Number 2 are the logical controls. These are the technical controls that protect the systems, networks, environments that process, transmit, or store our information and data. Some logical controls include authentication, encryption, and firewalls. Third are the administrative controls. These are the rules, policies, and laws for how we expect the users of our environment to behave. An example of this type of control is changing the password every 90 days. Defense in depth is another strategy for information security. It is a multi-layered defense or well-implemented defenses at different layers, which makes it difficult to successfully penetrate deeply into a network and attack the assets directly. So at the very least, we should have defenses on 5 layers. External network layer, which consists of external users outside our network. Internal network layer, which consists of the network in our corporate IT infrastructure. A host layer, which consists of the computers that are running the applications. The application layer, which consists of the softwares that manipulate our data. And finally, the data layer, which is an attacker's ultimate target, and it includes our databases and documents, etc. This slide shows the possible defenses in each of these layers. At the data layer, we can use encryption and access controls, for example. At the application layer, we can use single sign-on and content filtering, for example. At the host layer, we can use authentication, antivirus, firewalls, etc. At the internal network layer, we can use intrusion detection systems. Similarly, at the network perimeter layer, we can use firewalls and proxies. And at the external network layer, we can use virtual private network. So now let's look at the security design principles that need to be considered in order to implement secure software systems. In 1975, Salzer and Schroeder laid the foundation for this work and defined 8 design principles that are based on the ideas of simplicity and restriction. So if a system design is simple, then it means that less will go wrong and there will be fewer possible inconsistencies in the system, and it will be easy to understand. Similarly, if the system design implements restriction, then it means that it minimizes access. So an entity can access only information it needs, which is also known as the need-to-know principle. Similarly, it inhibits communication. So an entity can communicate with other entities only when necessary and in few and narrow ways as possible. So now I will discuss each of these 8 design principles one by one. So first is the principle of least privilege, which states that every program and every user of the system should operate using the least set of privileges necessary to complete the job. So the rights or privileges should only be added as needed to perform a certain functionality, and they should be discarded after the use. The next is the principle of fail-safe defaults. So this principle states that by default, the access should be denied to an object, and the entity should only be given explicit access when required. So in summary, this principle requires that the default access permission to an object should be denied. Next is the principle of economy of mechanism, which states that the security mechanisms should be as simple as possible. So if design and implementation are simple, fewer possibilities exist for errors. The checking and testing process is less complex because fewer components and cases need to be tested. Similarly, the interfaces to other modules and the interactions between them should be as simple as possible in order to reduce the incorrect assumptions about input or output parameters or the current system state, which could lead to unexpected and erroneous results. The principle of complete mediation states that all accesses to objects should be checked to ensure that they are allowed. For example, when a Unix process tries to read a file, the operating system determines if the process is allowed to read the file. If so, the process receives a file descriptor which encodes the allowed access. So whenever the process wants to read the file, it presents the file descriptor to the kernel, and the kernel then allows the access. So if the owner of the file disallows the process permission to read the file, after the file descriptor is issued, the kernel still allows the access to that file. This scheme violates the principle of complete mediation because the second access is not checked. the cached value is used, resulting in the denial of access being ineffective. The principle of open design states that the security of a mechanism should not depend on secrecy of its design and implementation. What this means is that the designers and implementers of a program must not depend on secrecy of the details of their design and implementation to ensure security. In other words, security through obscurity is not a good design principle. This design principle does not apply to information such as passwords or cryptographic keys. Firstly, because these are data and not algorithms, and they do need to be secret. There are issues of proprietary software and trade secrets which complicate the application of these principles. And in some cases, the companies do not want their designs to be made public because they want their designs to be protected from their competitors. Therefore, the principle then requires that the design and implementation should be available to people who are not allowed to disclose it outside the company. The principle of separation of privilege states that the system should not grant permission based on a single condition. In other words, more than one condition must be verified in order to gain access. So this principle is similar to the principle of separation of duty. For example, company checks for more than a certain amount must be signed by two officers of the company. If either of them does not sign, the check should not be considered as valid. So the two conditions are the signatures of both officers. Similarly, systems and programs granting access to resources should do so only when more than one condition is met. So this provides a fine-grained control over the resource as well as additional assurance that the access is authorized. So, for example, on Berkeley-based versions of the Unix operating system, users are not allowed to change from their accounts to the root account unless two conditions are met. First condition is that the user knows the root password, and the second condition is that the user is in the wheel group, which is a group with the group ID 0. So meeting either of the condition is not sufficient to acquire root access. In other words, they should meet both conditions. The principle of least common mechanism states that the mechanisms used to access resources should not be shared. Sharing resources provides a channel along which information can be transmitted, and so such sharing should be minimized. So in practice, if the operating system provides support for virtual machines or sandboxes, the operating system will enforce this privilege automatically to some degree. Here is an example of how the principle of least common mechanism is violated. So, serving an application on the internet allows both attackers and users to gain access to the application, so sensitive information can potentially be shared between the subjects via the mechanism. The principle of psychological acceptability states that the security mechanisms should not make the resources more difficult to access than if the security mechanisms were not present. So configuring and executing a program should be as easy and intuitive as possible, and any output should be clear, direct, and useful. If security-related software is too complicated to configure, the system administrators may unintentionally set up the software in a non-secure manner. Similarly, security-related user programs must be easy to use and must output understandable messages. On the other hand, security requires that the messages impart no unnecessary information. For example, if a user supplies the wrong password, the system should reject the attempt with a message saying that the login has failed. If it were to say that the password was incorrect, then the user would know that the account name was legitimate. So now let's look at the difference between data and information. Data represents the information. It is the physical phenomena chosen by convention to represent certain aspects of our conceptual and real world. The meaning that we assign to data are called information. So information is the interpretation of data. Data is used to transmit and store information and to derive new information by manipulating the data according to formal rules. So protecting information means to protect not only the data that directly represents the information, but the information must also be protected against its transmission through covert channels, which transfer information between processes that are not supposed to be allowed to communicate by the computer security policy. Similarly, information must be protected against transmission through inference, which is typical of the database systems, and it refers to the derivation of sensitive information from non-sensitive data. Example of inference and how to derive sensitive information from non-sensitive data. So this is a table in a database that is showing information about students, including their gender, their program, how many units that they have taken, and their grade average. So assume that there is a policy stating that the average grade of a single student cannot be disclosed. However, the summaries of student grades can be disclosed. So suppose that an attacker knows that Carol is a female student in computer science. So if the attacker executes the following two queries, number one, gets the count of all the female students who are studying computer science. Number two, getting the average grade of all the female students who are studying computer science. So since there is just one female student in computer science, the first query will return a value of 1. And the second query is going to return a value of 70, which is the average grade of female students studying computer science. So this way the attacker learns from query 1 that there is only one female student. So the value 70 returned by query 2 is precisely that student's average grade. So this way the attacker is able to retrieve sensitive information from non-sensitive data, which they were not supposed to know.